Hi, my name is Rene Martinez, and this is my video assignment for week 6 of FTT 122 Intro to Ammo and Ballistic. My instructor name is Alexander Fox Martin, and today is April 28th. Today we're going to talk about trajectory and sight. So this is the line of trajectory. You're going to align the sight. The sight right here, front sight, rear sight, to gain the line of trajectory. The line of trajectory will be set to the target. Now once the projectile leaves the muzzle brake or the muzzle blast, it will slightly rise and then meet the line of sight and impacting the target. Now for the second one will be gyroscopic drift. It's a phenomenon caused by the right hand twist in the barrel. Of course, you know, it twists to the right. Let's just do it this way, maybe it will be easier to see. We'll twist to the right. Now the nose of the bullet will slightly be offset, so it's gonna go twist and then move to the right because of that twist. This phenomenon happen even in zero wind condition, so you always gonna have gyroscopic drift. Now drag, let's talk about drag. So drag will be a lot easier if I can move this. Drag right here, it's a lot better. So drag, let's say the bullet is moving towards the right and the air pressure and air by going, let's say 3,000 feet per second, it will create a drag that it will hold the bullet and slow it down. That is the definition of drag in just a simple matter. So it goes straight and then the air will hit the nose and then the body of the projectile. Now we're going to talk about Magnus effect. Magnus effect is a reaction to the airflow. If the wind hits the projectile from the left and the rotation of the projectile is going right, that means the projectile will go up, will roll up, and vice versa. So say going to the right, air is hitting to the right, it will hit the projectile, and because it's going right, the projectile has been going right, it will rise up. Now if the wind is hitting towards the left and it's gonna hit the projectile, that means it's gonna go down. That is the Magnus effect. Second one, which was one of the most complicated for me, is the Coriolis effect. The Coriolis effect occurs when the projectile is fired the right angle, north to south, south to north. The earth rotation will vary on the north of the projectile will move towards the right, and in the south will move to the left. So right here, projectile shooting from the north, it will move to the right, and vice versa, will move to the left. Now another one is the Etodos effect. This effect is due to the movement of the earth. When the projectile is fired to the target, will move towards, this is shooting to the west, so we're shooting to the west, so from east to west, the projectile will be here, and this is the earth rotation. Instead of going strictly in, this means the target is moving towards the projectile. So what this will cause is that the projectile will hit about 2 inches higher. Now if it were shooting to the east, shooting to the east will rise. and vice versa. And shooting to the west will go down 2 inches. For 1 second, this will result in a low impact. So this is the one that I got. So shooting to the west will result to a low impact of 2 inches. Shooting to the east will rise 2 inches. That's the best way that I can explain it. And of course, we have the equator line where the mass of gravity will pull down the projectile even more. So that is one of the examples. Let's say you're in a car, you hit a bump. Of course, gravity is going to bring you down. Now, shooting vertical angles, it only works perpendicular for newer shooters. Gravity only works perpendicular. For newer shooters, we'll be missing a lot by not counting gravity. So right here, let's use the tall one right there. And of course, we're shooting from here. So newer shooters are not counting the gravity line. So they aim, and what it does is it shoots high. Instead of counting for the gravity line and actually moving the line of sight to impact the target how you want it. That will be my best explanation of shooting in angle or vertical angles. Now we're going to talk about transonic ballistics performance. As a projectile is moving at supersonic speed, now the drag will slow it down, and drag and force, as a projectile goes supersonic to subsonic, it will make it tumble. It will be like a tumbling in the back, and this tumbling is called transonic ballistic performance. So it will tumble, and this can affect accuracy, because the bullet can tumble and hit this way, or it could just tumble completely if it doesn't regain the center of mass and keep the rotation how it's supposed to. So this can greatly affect accuracy. And that's my week 6 video assignment. Thank you.